Let's clear the page here and move on to the next question. So this is question number 2. Okay, so here we're asked, how do you find the average velocity of the position function s at t 3t squared minus 6t on the interval from t equals 2 t equals to 5. So we'll just write out the equations here just so we have them. So 3t squared minus 6t, and from t equals to 2 to t equals to 5. Alright. So let's go through the junior tutor's answer and then we'll verify it. So the average velocity of a function is defined as the total displacement divided by the total time. So this is correct. We have given the position function this, and we have time. So we can evaluate, yes, at 5 and 2. So here we just substitute 5 minus 2. So there's just substitution for the different times. And then average velocity is 45 divided by the time, which is 3 seconds, and to get this question. So overall, the process looks correct. Let's just verify the calculation. So we'll substitute. Here they do everything in one step. We'll split it out into a couple of steps. So we'll just evaluate at s equals to 5 and at s equals to 2. And we want to figure out the displacement at time equals 2 seconds and time equals to 5 seconds. So we can just plug this in. So this will give us 5 squared minus 6 times 5, and then the bottom would be 3 times 2 squared minus 6 times 2. So we have 5 squared, which is 25, and then we have 3 times 25, which is 75. So 75 minus 6 times 5, so this is just 30. So we have 75 minus 30, and we end up with 45. And then the next part, so 3 times 2 squared, so 2 squared is 4, 4 times 3 is 12, 12 minus 6 times 2, 12, so we have 12 times 12, which is 0. So at s, so the position function that we're given, when we substitute the time value 2, so at time equals to 2, the displacement is 0. So they're at position 0. And when we substitute at 5 seconds, we get 45 displacement. So here in about, from time 2 seconds to 5 seconds, we have 45 meters, I believe, in displacement. So we'll do the velocity. So average velocity is equal to the displacement. So let's say delta d over delta t. So the change in time, distance over the change in time. So we'll do the final distance. So at time s equals to 5, 45, which we calculated over here, and then subtract 0, which is at s equals to 2, 0. So we have final position minus initial position, and then we divide that by final time, which is 5 seconds, minus 2 seconds, which is initial time. So we have 45 divided by 3, so 5 minus 2 is just 3, and then 45 minus 0 is just 45, 45 divided by 3, that just gives us 15, and then meters per second. And that is our final answer over here, 15 meters per second. So this is the average velocity given position. So this solution is correct. So you can see the difference here, how we calculated. So here we just substituted in and then did the subtraction. Here they did the subtraction in the same step for displacement. So they did the evaluation of 5 minus 2 and 5 minus 2 all in one step. Here we just split it out into multiple steps. So correct answer. Great job. And we'll mark this as correct.